Welcome back to the Gabster channel. My name is Gabby. Today it's a special one. We're going to build something a little bit more simplified. Most of you recall me building this beautiful streamer a couple of years back, and also my DAC, the D11, recently. And I got a lot of comments like, can you build something a little less complicated? And maybe for most people that don't have a lot of DIY experience that I can actually build. And today is a day, yes, I heard you all, and this is what we're gonna show you, is how to build something a little simple. So we're gonna build this. This is the Gabster D5, but you can call it anything you like. It's a streamer, and it's a really incredible streamer. We'll start with a simple one, and then we'll start to add a little few things here and there and make it better and better. Don't take me wrong, the most simple version is really good. These are using some of the very high-end components. Most of these components are from Ian Canada. I started using his parts a few years back, and I fell in love with the design and the quality of build. They are designed in Canada here. These are not your average products that you can pick up here and there for cheap. They are not expensive, but they are really very well built. They're not as cheap as some of the stuff you would buy maybe off Aliexpress and stuff like that, but when you're doing DIY, you're saving a ton of money. You really don't want to get the cheapest component. The whole idea of doing a DIY is to get the best possible sound you can build yourself. And for that, you need some quality engineered components and parts. And this is where the stuff from Ian Canada comes into hand. If you're new to the channel, please consider subscribing. It will really help the channel to keep growing. Also, like the video if you seem to like it. It will help me out as well. So we're gonna dive right into it, and towards the end we'll talk about different things. I'll talk to you a little bit about some of my future projects and some of the things that are coming in the pipeline. And hopefully you'll find this video interesting, and at least it will help some of the newer DIYers build something really amazing. So we are going to build this almost in real time. So just basically we're going to build it together, and this way you get an idea that's really not that complicated at all. We got a box here of different goodies. I'm going to put a link below of every part we're using in this video, so you do not have to write anything down or anything. So it will all be down. So these are all the parts we're going to need to build this project. I unpacked all the parts, and what do we have here? And this is the PurePi. And both sides we're gonna have to put, doesn't come with the batteries because they're hard to ship, special regulations for batteries, so you'll have to buy your batteries separately. I'll put a link too for the batteries if you like, but these are easy to find, 18650 I mean. And then this is the FifoPi Q7. The FifoPi comes with actual clocks. These are fairly decent clocks, but later on we will upgrade the clocks. But for the sake of this video, remember, we're going to keep this as simple as possible. We're going to keep the same clocks that come with it, because they're actually not too bad of clocks. And then we've got the, this is our I2S output. It's called the HdmiPi Pro transport. And then we have the screen here. Basically it's called the MonitorPi display, and these are our little spikes that we got off Amazon. Let's not forget about the Raspberry Pi. This is the Pi 3B. You can get a 4 as well. 3B, people there's some ideas that it might be a little bit better for what you're doing. If you're using a USB, which we're not here, then the 4 is better. But since we're not using any USB functions, the 3B is a little bit better. But please do your own homework. I'm just and showing you what I do, but I would like you guys to observe safety standards and make sure you know what you're dealing with here. There's some ultracapacitors, some batteries, and things can, if you're not careful, you can have accidents and cause harm to yourself or to your property. All right, so let's get building. So this is the PurePi. It's double-sided. On this side, I already loaded the batteries. So what you want to make sure when you put the batteries in, they're pretty easy to put in. Just slide in, but make sure you observe the polarity so that the negative is onto the negative and positive on positive. Otherwise, you can short them and bad things could happen. Next thing what we're going to do is going to start putting the standoffs. So we're going to put those standoffs here, and that's going to give us a little ground for the PurePi so we can work on it a little easier. The PurePi is, its role is to supply nice clean power to the system. So there's two parts that run on the batteries basically, and also the ultracapacitors play a role also in cleaning the power. And so I'm doing this in real time, and as I do it I'm going to talk to you a little bit about each part. So this part is a PurePi. You can buy it for $86. You can either buy it from Ian Canada's site, or if you prefer, you can buy it from Audiophonics in Europe. I'll put links below on where to get them. We'll just tighten those a little bit, and here we go. It's all assembled with the spikes, so it's starting to look cool already. The next thing we're going to do is, so we're going to flip this around a little bit. Here you could see there's some pins, and what's going to happen is we're going to put the Raspberry Pi on top of that. So we're going to, before we can put it on though, we have to put standoffs in those holes. And make sure you use the standoffs that come with the PurePi. They're a little short, they're about 7 millimeters. For each hole you're going to put one standoff. So we're going to flip it like this just to make it easier. So this goes into the hole in here. And we screw that in. And there you go. You could see how the standoff here is sticking. We're going to do all four. Alright, so we got all four standoffs here, and now we can actually put in the Raspberry Pi. So the pins go where those little pins are, and the holes should all match. So we're gonna put it like this, and here it goes, just like that. Now on top of that, now we're gonna use the standoffs that came with the FifoPi, and we're gonna use those on top. And that's going to lock the Raspberry Pi in place. So these are all tight now, and that's the Raspberry Pi in place. So next, make sure those two are tight, because that's what pushes the Raspberry Pi to connect those pins underneath it together. Now we're going to put the FifoPi on top. You could see the FifoPi, it's got two rows of 40-pin connectors. You can see the bottom. This should connect to this part here. So that's gonna, but as soon as you line up the holes, it automatically lines up. So you really don't have to do anything special. So the only thing you have to do is once it's the holes are lined up, that you have to push it a little bit, and just to make sure it goes into place. So that's into place. So now you're going to put 4 more standoffs. Now you're going to need to order 2 sets of extra standoffs, because the HDMI Pro transport doesn't come with any, neither does the top plate, the plastic cover. Alright, so you need to order those two sets of standoffs. You can get them from Ian. They're 11 millimeter basically in height, or you can also buy them off something like Amazon. You can buy a big box of them sometimes. They're not too expensive. A couple bucks for a set of 4, I think. So yeah, so we're gonna put those 4 standoffs on top. And here's the 4th one. So on the FifoPi, the FifoPi, this particular one is the flagship version, and this is the Q7. It's $189. If you don't want to spend this much money, there is an MIA version for $99. It's almost very similar, but this one is a tad better. Here you could see the clocks. So it comes with a set of 2 clocks, and they're decent clocks. So I would suggest you listen to them first, but you can get better clocks. But for the sake of this video, we're going to keep the same clocks the way they are. To change the clocks, it's just a matter of pulling this here. You can see it's got 4 pins, so you can get a different clock and plug it right in here. So it's fairly simple, and you can have different sounds. Almost like putting a different tube in a tube amplifier. You get slightly a different sound. But like I said, we're going to keep them here for now. We're going to move on, and what we need to do now is connect a cable, some wire from the power here, because this is the power that comes from the battery, and we're going to connect it to the FifoPi. So the FifoPi will be running on battery power. So I've got a little small cable here. It's important to observe the polarity. So negative is outside and positive is on the inside. When you want to do this, the first thing you want to do is you got to turn these anti-clockwise quite a bit till they open up. Otherwise they are closed. Once they're really open, then you can put the cable in. We're going to put this one here, this one there. And now we are going to tighten those screws. And tighten the other one. I just like to support it a bit, because you don't want to push too hard, because the whole board could disconnect from it's only connected on the edges, because it's meant that you can actually break it out of the support if you choose to put it in a different setting. So same thing on top. We're going to unscrew these. I've already actually unscrewed them, and then you're going to put negative on the outside, positive on the inside. But always read the polarity of the jumper pins here, because don't just take my word for it. Let's tighten this guy a bit. There you go. So here it says ground around here, so we know here is ground, here is 3.3. And then give them a tag that makes sure that they're really connected. Sometimes you're fooled that you're connecting, but you're actually tightening on empty. So here we go. So now we've got that connection. The next part is we are going to put the HDMI Pro, and so this is again the pin that's on the bottom here should line up with the first row here, but it's just a matter of really lining up the 4 holes together. So we're gonna put them like this and just support the board a bit, and we're gonna push them in, and that goes into place. Okay, always check on the other side, make sure it's in, so that's good. So now that part is in as well. And one more thing we need to do is connect the UFL cable. So this is a cable that's gonna go from the master clock on the FifoPi. So basically it's the last one of those little EFL connectors. So it says master clock on it. So you gotta line it up properly and then you push it. And here it is, it's in place. And then there is the master clock input on top of the HDMI board here. So we're going to also line this up again. And here it is. You should be able to, if you turn it, it's still locked into place. So I'll just zoom in a little bit more. So here it is, the input is here and the output is on the bottom down here on the FifoPi. The HDMI Pro board is $125, and like I said earlier in the video, if you don't want your I2S output and you want, let's say, optical or coaxial, you can get the other board, the the transport AES, and then you can have different connections. I don't suggest you put both. I mean, decide which way you want to go, because the simpler the better. The more you add circuitry, the less your sound quality will be. So if you don't need it, no need to add it. And so yeah, so this is gonna go pretty much on top here. And again, if you don't want to spend this much money, there is a board that has actually all connectors. It's got the I2S, the AES, the coaxial, the optical, all on one same board, and it's for $79. And so you can use that. It's not bad. I've used that before. But this is the flagship version, so we're gonna remember this is supposed to be one of the best of the best, so we're picking some of the best parts. Now that we have the HDMI transport board on, we're gonna put another set of those standoffs. And this is the last one. There you go. And so we're making very good progress here. So this one you don't need to put any extra power. It's powering from the board below it. Next thing you want to do is you want to grab the monitor. It's a MonitorPi, and we're going to flip this around. And you'll notice here, remember on the FifoPi there was two sets of connectors, 40-pin GPIO connectors, what we call. So the monitor is going to plug into the one that's sticking out the most. So this one you really have to make sure it lines up properly. If you don't line it properly, you could short it. So make sure the lines are good. And when you're pushing, don't push too much on the board. I would try to push a little bit on the actual connector, just in case you do not want to, and support the board below it. There you go. You can push it a little bit on the top, but start by helping it a little bit. And so that's the MonitorPi. So the MonitorPi, it's a display basically that shows you what's going on, and it's $49. You do not need to have it. This is an optional. It just adds a little bit of information of what's going on. Some of the purists believe that why are we adding a monitor? If we don't add a monitor, we're going to have less noise in the system. The good thing though is this is not plugging into the FifoPi clean side. It's only plugging into the dirty side, so it's like before the galvanic separation. So it shouldn't in theory affect the sound too much. But again, it's a little debatable issue. I like to have it, but some people prefer not to. And on top of everything, we're going to put the plastic cover. This is purely cosmetic. It has no sound value. The only thing is it protects the board from too much dust falling and you know, in case you stick your fingers here. It's not a full protection, but it's just more also, it's also decorative. It's $10, but it's an option. You can take it or not take it, but for the sake of the video, we're going to use it. I think it's actually pretty cool. So yeah, same with the those spikes, you know, you don't have to use them. You could use something else, and we will in a future video try something different. These are from Amazon. I don't know if I mentioned they're $25 for a set of 8. I will put a link below on how to get those. So there you have it. This is the finished product. As you can see, it does not need any major knowledge. It's just a matter of like Lego. Just put them on top of each other, couple of screws, and off you go. Don't underestimate this little system. It sounds like a quirky little cheap thing, but this is not. This is using top of the state-of-the-art designs, and there's some really great engineering going on behind this. I will link to Ian's website, and the documents of each one of these boards is full with valuable information. I strongly urge you guys to read the documents, because that's how you really understand what's going on. Also, it goes in length on how to connect everything together. One last thing is we need to plug some power into this, and all you need is one USB-C cable, and it goes on the bottom here, so you could see the connection. So what I am using, it's by a company called HIFI. I have no connection with them. I used this product before, and I've tested it in a previous video. I'll put a link in the description and also on top if anybody want to see that video. And the other option is to use a linear power, but for switching power supply, this is a really good switching power supply. It has very low noise, and it's not your typical switching power supply. And because you need 2.5 amps, otherwise a linear power supply, you're going to need quite a beefy power supply. And what's nice about the HIFI is that it comes with a whole bunch of different connections. Say you live in Europe, it's got different parts. It has different connections and adapters. Pretty much you can connect to anything. In our case, I'm using the USB-C connector, so it's a little extension piece, and it comes with the HIFI as well. So you just have to put it at the end here, and now you take your USB-C and you plug it in here. So when you plug it in the first time, you're going to have a light here saying that's got power. And I'm just going to move this away. And the first time you plug it in, it's going to need to charge the batteries. And that could take anywhere from 10 minutes to a couple hours. Depends on your batteries and how much charge is pre-charged in them. Some batteries come pre-charged to 20%, some have more, so it will vary. But when it's fully charged, there will be additional LED lights in here, and they'll start to light up. You can peel the double-sided film on the plastic if you want to get that clear look. It took me a while to figure out that there's actually these two sides. They're very hard to find, but with a little carefulness you can get them. Also, one other thing is the batteries that you buy, make sure you get the 3.2 volts, not the 3.7 volts variant. They're quite different. So these are the 3.2 volts. And so you can peel this, and that becomes the clear. And that's how it looks, and then you can fasten the screws there. And there we go. That you get the clear version of it now. The second thing you want to do is you want to put some software on the Raspberry Pi. Your card on the Raspberry Pi is located right here, and it might be a little hard to pull it with your fingers, but maybe a piece of tweezers or a little piece of small little pliers, and you can pull it out. So what I do, I use something like little small pliers like these. I'll just go and grab it and just pull it. It's pretty simple. And then you can put it back. And so you want to install the software that you like. So you might want to put Volumio on, or in my case, I'm putting Rupi, so I'll be using Rune with it. So I'm not going to go into the software part, so just follow your basically there's lots of links about that, or we can do that in another separate video. And once you put the software that you like, you can push the power button here. I'm just going to click it on, and you can see it starts to go. You also need to connect a network cable to it, and then you'll have full functionality of the board. I'll put a link below as well. There's a forum about all this stuff where you could follow. It's been going on for years, and there's been lots and lots of members on it, and you can interact. And actually, it's a place where if you stumble on something, you can refer to for help, and people a lot of times will help you. If you ask a question, they will help you. Sometimes Ian will chime in, will also help you. So it's like I said, it's a DIY community. So in future videos, what we're gonna do is we're gonna although this is a really capable system, don't underestimate this. This is really good the way it is like this. But we can do a little improvement. So we can change the clocks, for example. We can put it in a different case and have something more fun and more professional, if you can say that. And we can try slightly different configurations. We can add a DAC to it and make it a full DAC. So there's a lot of possibilities here, and so I'm going to be doing a little series of videos about this, and they're going to be all simple. So how does it sound? Most of you are wondering. It's actually, I was very pleased with it. So pleased that it was very hard to distinguish it from my big very elaborate streamer that I've built a couple of years back. Technology of the products have changed also, which helped a lot. There's some really good components that Ian's been producing lately. He's updated quite a few of his previous boards to a higher level, even better. So you definitely can hear a small difference in the sound quality. So if you're new to DIY, this is something easy that you can build that doesn't require to know a lot. So just do your own diligence. I'm not going to be responsible for your mishaps. Just do this at your own risk. I will be doing a couple more videos in this series. We're going to upgrade this streamer a little bit here and there and do a few little tweaks, put it in different enclosure, have some fun with it. But for most of you, you can build this. This is really good, even with the original clocks. It's not bad. Imagine upgrading the clocks and doing a few tweaks. We can even bring it to a higher level. So stick with the channel. If you're new, please subscribe. Please like the video. It will really help the channel. If you want to hear about my speakers that I've built a while back, the GS11s, I'll put a link in this corner here. If you want to know more about the DAC, the D11 that I've built, I'll put a link here. And if you want to subscribe, there'll be a little speaker icon. Just click on that and go from there. Take care, and I hope to see you again.